Hello everybody, my name is Paul Beckwith. Since I put out a few videos on the Antarctic ocean overturning circulation, currents slowing down as a result of less and less sea ice around Antarctica, I've been asked many questions about the implications of this for humanity, like what is happening. So as you know, I've talked about abrupt changes in the climate for many years. So this is a perfect example of an abrupt climate system change. Where I am right now is I'm over in Quebec. This is the Ottawa River behind me with Ontario on the other side. And you can see I'm at Lac Leamy Point, where there's a National Capital Commission archaeological dig. They found arrowheads at this site going back, dated to about 5,500 to 6,000 years ago. And part of what I'm talking about with the ocean currents abrupt changes is the AMOC, the Atlantic Meridional Overturning Circulation, abruptly shut off. The last time was about 8,200 years ago, and it was only off for about 160 years or so. In that case, it was a cooling period. So that was the most recent time we had a shutdown of that system. And I'm going to go through and lead you through the changes that we can expect if we get both an AMOC shutdown or near shutdown combined with an Antarctic ocean overturning circulation shutdown. If they both shut down, you know, what we can expect to happen to our climate and sort of the time frames involved. So in the background, I don't know if you can see it, but there's a waterfall up here, you know, where I'm pointing right up here. And if I scan over here a bit more, you can see these points, these spikes. This is apartment buildings in Ottawa. Okay, so, and before I get going, I just want to scan over. So there's a tent set up where there's public events. The public's invited to come and do some digging, archaeological digging. Okay, so you can see more tents over in the background there. And like I said, you know, people are finding all kinds of different things. They're mostly interested in First Nations artifacts like arrowheads and you know, other tools that the First Nations people used here. Most of the stuff dates to somewhere between 1,000 and 2,000 years ago, but they have found arrowheads which they've dated back to 6,000 years ago. And this whole region, of course, was covered by ice during the last ice age, which peaked about 21,000 years ago. You'd have 2 or 3 kilometers of ice over where I'm standing right now. And then the ice melted off and was mostly gone. There was still some of it around about, you know, 8,000 years ago. The 8,200 year ago event, we were basically under several hundred feet of water here. Lake Agassiz, which extended across the entire region of where all the Great Lakes are now. It was thought that a glacial dam broke and a big pulse of water went into the North Atlantic 8,200 years ago, draining a lot of the lake, uncovering this areas like this, but also that fresh water into the North Atlantic shut down the AMOC in an abrupt event. Okay, so let's get back to what I want to talk about. So what happened if both the AMOC and the AOC, the Antarctic Overturning Circulation, both shut down? And basically, the global climate gets drastically destabilized. There is rapid regional cooling. Weather patterns in the northern hemisphere completely shift. Also, well, it's a global thing. We would get a severe sea level rise on the U.S. East Coast, several feet, in fact, 0.7 meters, 70 centimeters. There'd be profound shifts in the tropical rain belts, where they occurred and how intense they were. Of course, extensive marine ecosystem disruption, and we get amplified extremes in cyclonic storms, heat waves, droughts, torrential rain. So more and more extreme weather events could be expected. So what actually, so all of these things can happen. Basically what we'll have done is a disruption of the heat transfer from the equator to the poles would be greatly reduced. So the poles would basically cool somewhat, become more isolated, or at least the Arctic region would be. With less heat going up to the Arctic via the ocean currents, the equator and the tropics would warm significantly. So low latitudes would have a big heat gain. Of course, it depends on how much the ocean currents slow and the ratio of slowing. Like, you know, we used to think that the AMOC slowing down would maybe strengthen the Antarctic overturning circulation. The AMOC slowing down a lot could actually increase the Antarctic overturning circulation, but it turns out that, you know, we're seeing a massive loss of sea ice around Antarctica, which indicates that the Antarctic overturning circulation will actually be slowing down, not speeding up. So there's this wild card, because often there's a seesaw in what happens at the two poles. But, you know, all of these disruptions will lead to global disruptions. And of course, the biggest risks are, you know, water risk, water supply, fresh water supply for drinking, and food risks to humanity, not to mention the extreme warmth. And there'll be lots of different regional climate pattern shifts and, you know, land-ocean contrast effects and global temperature pattern shifts. So basically in the ocean, with more stratification of the ocean and less vertical mixing of the ocean, this is a huge problem, especially with southern hemisphere vertical mixing of the ocean decreasing, because the southern oceans are an enormous carbon sink right now. So about half of the CO2 that humans emit by industry, etc., you know, are absorbed into the ocean fairly quickly. The CO2 is dissolved in the ocean water. You know, at the poles, when the sea ice forms, it rejects the salt, so you get cold, dense water, and it's oxygenated, and it's got lots of carbon in it, and it sinks to the ocean floor at both poles. This is occurring. So if that system slows down significantly or even shuts off, we don't have that much carbon going down to the ocean floor, so there's a lot more carbon in the surface waters, therefore in the atmosphere. So if we lost, if you consider that CO2 levels globally have been rising as high as 3.5 parts per million per year, you know, this last year recently, then you could expect that number to perhaps double with the ocean sinks failed, and also, you know, the Amazon rainforest has traditionally absorbed a lot of carbon, and it's no longer doing that. So we're monkeying around with the entire climate system, but you could expect a huge increase in greenhouse gas rates in the atmosphere with a failure of the Southern Ocean sink. But not only that, the monsoons, the tropics warm significantly, so the monsoons change significantly. They change location, they move further south from where they are, so that could lead to droughts where they presently deposit a lot of rain, and flooding in southern regions. The ocean's circulation is very important for a number of reasons. The vertical mixing is very important. I've mentioned the carbon sink job of the Southern Ocean, which will fail with the vertical overturning, slowing down, or even stopping. But also, water comes up from the deep ocean floor, and that water is high in nutrients, and that's very important for marine ecosystems around the world. So if that overturning stops and there's more stratification of the ocean, we will have a huge deficit of nutrients at the surface, and this will be hugely detrimental to marine life around the planet. Not only that, but the downwelling of the surface water is very important because it's high in oxygen. It carries oxygen to the deep ocean. So not only is the deep ocean water refreshed, if you like, from surface water, but oxygen is brought down, which is very important for marine ecosystems that live in the deep. And of course, if they don't get their oxygen, then they're going to fail. Also, salinity is a big factor because it's the saltier water that descends down to the deep ocean. So with that saltier water not descending down to the deep ocean because it's just too warm, and there's, then the salinity regime of the whole ocean can also change. So there's lots of these things going on, not to mention the social fabric of society, the misinformation and disinformation, the anti-science sort of voodoo fantasy stuff that is coming out of some major unmentioned country right now, just south of me here in Canada. This sort of stuff it's a huge problem. Compound that with the plastification of people's brains over time, and we're not heading to very happy times. So let's go back to more of the details of what actually happens if the AMOC shuts down. What happens if the Antarctic overturning circulation shuts down? Okay, so you can look at these things separately and then combine them to look at what happens if both of these sort of things occur. So if the AMOC shuts down, we obviously get a major cooling in Europe, mostly Western Europe. The whole North Atlantic region cools by several degrees Celsius at least. There's less precipitation and more extreme weather in European countries. The Gulf Stream no longer taking its present path up to the Arctic, bringing heat there, means that the heat builds up and there's sea level rise really rapidly along the North American East Coast. So we could expect along the Atlantic coast maybe sea level rise, according to the modeling, etc., of up to 70 centimeters, which is about 2 feet of sea level rise on the eastern coast of the U.S. and North America. We get shifts in tropical rainfall. The ITCZ, Intertropical Convergence Zone, shifts south. So we get drought in the African Sahel, more rain south of that. The agricultural shifts would be drastic. We would have a huge reduction of arable land, especially in Scandinavian countries. In the UK, perhaps a drop of 75% in agriculture. You can think of this as Viking era 2.0, because the Scandinavians will have to go elsewhere for their food, which is exactly what happened to trigger a lot of the Viking excursions back in, around 900 Common Era to 1100 Common Era, something like that. Make sure you watch those Netflix Vikings movies to see how to survive in those situations. Of course, the marine ecosystems and fisheries are severely impacted by these ocean changes. Less carbon going downwards, less nutrients coming up, oxygen not going down to the deep ocean floor. So huge ecosystem upheaval in the oceans. Now, what happens if the Antarctic ocean circulation slows significantly and shuts down? And we're seeing this is the increased risk of this from the collapse of sea ice around Antarctica since 2015. So basically, we would have a big reduction of renewal plus oxygenation of the deep waters in the southern hemisphere around Antarctica. The ocean life worldwide would be negatively impacted. We'd get a shift of the global carbon cycles, as I've mentioned. CO2 in the atmosphere would skyrocket, maybe even double the present rates, and this would happen we're talking about shifts that can occur, in less than a decade. There'd be a reduction of cold bottom water replenishment off Antarctica. So this would destabilize the polar currents. It would, it would affect we're seeing a great reduction of Antarctic sea ice, causing this reduction of the AOC. Basically, the weather patterns in the southern hemisphere completely shift as they do in the northern hemisphere. You get an amplification of global warming, And of course, if both things shut off, you know, this is where a lot of the uncertainty and you know, craziness happens, because, you know, we thought that if the AMOC, for example, greatly slowed down and shut off, that the Antarctic version would increase in strength. I mean, that could still happen, but, you know, what we're seeing is a scenario where both the AMOC and the AOC are slowing rapidly now. And if they both were to halt, the Earth's heat transport system would basically be disabled. Northern hemisphere, I said, would cool sharply. The tropics would, and the lower latitudes would warm greatly. There'd be dangerous temperature gradients between these regions, and that would destabilize the jet streams and create new patterns of atmospheric flow, which we need to try to model and find out more about. Of course, the patterns of the monsoons, the wet, dry seasons, the cyclonic shifts, everything basically changes. Ecosystems collapse both in the ocean and on land. And, you know, basically this has profound effects on humanity, on civilizations, on ecosystems, on species, and, you know, much of the what we take for granted is basically foobarred, if you know what that expression means. So what else can happen? Well, the AMOC collapse is driven, of course, often by freshwater input. So and the AOC, the Antarctic version, the sea ice melt is severely reducing it, as we're seeing. So let's have a look at what has happened in history, in the Paleo records, the climate records. So we've had abrupt ocean circulation events, shutdowns, and failures in the Paleo records. There's multiple examples from history. There's multiple times we've had rapid, dramatic climate shifts on decadal to centennial, 100-year timescales. There were many changes in the AMOC during and after the last ice age. Okay, so let's talk about some specific events now. And I've got some notes on this that I'm just referring to. Okay, so the Younger Dryas you may have heard of. So 12,800 years ago, we think there was a large influx of meltwater from the glaciers over North America into the North Atlantic due to collapsing ice sheets as the ice was melting from the last ice age. And this large influx of meltwater, fresh water, halted the AMOC. It shut down the Atlantic Meridional Overturning Circulation. It resulted in a rapid cooling in Europe and North America for 1,300 years, despite the overall global warming trend. And after 1,300 years, it looks like the AMOC restarted to resume the warming trend. So from 12,800 to 11,500 years ago, we had this Younger Dryas event, this AMOC collapse. But we've had a more recent one, it looks like, than that. But first of all, you know, going back to deeper time, so 60,000 to 10,000 years ago, in the Greenland ice cores, they show us that there's been over 20 abrupt warming events recorded in Greenland. And the temperature change was as much as 15 degrees Celsius in a decade or less. So it happened very abruptly, very, very quickly, where the AMOC stayed shut off for a time and then restarted. Okay, we also have this phenomena called the Heinrich events. So we'd have a major warming of the ice, and eventually that could, the glacial ice from an ice age period, and that could eventually lead to a massive discharge of icebergs from the Laurentide ice sheet, for example, is the most recent one. The Laurentine ice sheet covered North America, and if there was a rapid, massive discharge of icebergs across the Atlantic, released large amounts of fresh water from the meltwater all of a sudden and stopped the AMOC and led to a rapid cooling period again. So you would get a seesaw between warming and cooling. Okay, and the most recent time period, as I mentioned, which has a connection to this site where I'm at, right, the 6,000-year-old Arrowhead, well, there's an 8.2 kiloyear event, or 8,200 years ago. We had a profound cooling of this region for 160 years. Basically, we're leaving the last ice age, a lot of warming. And then, poof, 8,200 years ago, we went to a massive cooling for 160 years. The cooling is linked to a sudden influx of fresh water, meltwater, that was from Lake Agassiz, which broke through an ice dam and drained water into the North Atlantic to shut down the AMOC. Lake Agassiz was a massive meltwater lake which covered the area, went far beyond the existing area of all of the Great Lakes combined, so massive amounts of water. So it was basically considered to be the final drainage of the glacial meltwater from North America, which shut down the AMOC and caused that cooling, and that lasted for 160 years. Remember the Younger Dryas? It lasted for 1,300 years. So all of these things have been recorded in the Paleo records. And, you know, we know a lot more about what's happened in the Arctic, and, you know, there's people living, a lot more land in the northern hemisphere than the southern hemisphere. So we don't have good data on what's happened during all of these time periods when this stuff was going on in the northern hemisphere, what was happening around Antarctica and southern hemisphere. But there's more and more evidence emerging showing that there were also massive regime shifts in the southern hemisphere around Antarctica. And we're seeing that since 2015 with the collapse of sea ice. So the key thing is that these sort of things are indicating that the Earth climate system is capable of massive abrupt changes. You can have these massive abrupt changes in ocean currents and therefore in atmospheric circulation, jet streams, everything else. In less than a decade, they can be triggered. The temperature change can be as much as 15 degrees Celsius, as recorded over Greenland from the ice cores. So the temperature changes can shift extremely fast. These would be mean temperature changes, and this would have massive effects on temperature, precipitation, on global climate and global weather patterns. I mean, the proxy records, the ice cores, the sediments, the isotopes, they reveal that there's been many, many massive changes in the ocean circulation system, and they, of course, have led to massive changes in the atmospheric system. So basically, this video again is sort of an answer to it. It asks a lot more questions than it provides answers to. But what it shows is, what I really wanted to emphasize is that the changing ocean current is a really big deal to all humans on this planet. It's a big deal to our civilization. It's a big deal to our ability to grow food. It's a big deal to our to the climate patterns that we're used to. And we've been seeing massive changes in the Arctic for many years. And since 2015, we're now seeing massive changes in Antarctica. So, over time, the picture will become clearer and clearer as to what we can expect. But I've, given you a lot of food for thought, I hope, with this video, and really try to emphasize that the climate system is capable of huge, abrupt changes that occur in less than a decade, with huge temperature swings. And that will greatly affect how we grow food and where we can grow food and our fresh water and all the rest of it. So anyway, thank you for listening. Please go to my website, paulbeckwith.net, and donate to PayPal to support my research and videos, or you can go to Patreon and set up something there. I like to provide these videos not from behind a paywall. They're free, they're open source to everybody, and I'd like to continue doing that. So in order to continue doing that, I'm going to have to do something slightly different, or appeal for more financial support from people that are watching me. There's about 44,000 subscribers to my YouTube channel. So like if you just pledge like $5 a month or something, then I could continue into the indefinite future. So anyway, thank you for listening, and yeah, bye for now. It's a really cool site. If you're in the Ottawa region, you can Google the Lake Limy Park Archaeological dig, and they often have this open to the public. As you can see right now, it's a fun activity for all the kids and everything, and you can actually come and sift soil through strainers and get some guidance from professional archaeologists, and they can tell you what to look for. And it's right on this site where they found the 6,000-year-old arrowheads. So, and then I just talked about the 8,200 year ago event where the lake Lake Agassiz, which covered this area in hundreds of feet of water, basically abruptly drained into the Atlantic, shutting off the AMOC. So it's an interesting connection from this site. I thought this site was perfect to do this particular video. So thanks for listening, and yeah, bye for now.